Now that we've collected our data, the next thing we need to do is to figure out what is the relationship between how much cholesterol standard we have and the absorbance values that we measured. We can then use that relationship to figure out how much cholesterol is in our unknown. And to do this, we're going to make a standard curve. That is, we're going to do a graph where we're going to plot amount of cholesterol or cholesterol concentration against the absorbance we get. And we're going to see what kind of relationship we have. So in an Excel spreadsheet, I've put in 2 columns. And in this column, we have the milligram percent of our cholesterol standards, of our known, and then we have the resulting absorbance at 505 nanometers. To make a graph, simply select this area, and then we're going to put in up here, we're going to select chart, and we are going to put in a scatter chart. Click on that, and it's going to be marked scatter, and here we have it already. It's generated this graph where we have along the x-axis here we have milligram percent cholesterol. Along the y-axis we have absorbance at 505 nanometers. Now we can change all of this. There are various quick chart layouts available here. If you click on them, so this one for example, it's given us a box to put in titles, so we can put in here milligram percent cholesterol, and here we can put in absorbance at 505 nanometers. And you can see that it's plotted our points. What we don't have yet is any kind of fit to these data. It's put in a straight line, kind of by default. And if we look at it, we'll say, yeah, that looks good to me. It looks like there is a linear relationship between how much cholesterol we have and how much absorbance we get. So that's really nice, because then we can just use a simple equation to relate the two. So to find out what that equation is, what we need to do is to show the linear fit to the data. And the way to do that is by doing a right click on one of these data points, and then we click Format Trend Line. And under Format Trend Line, we click on Options, and we say Display Equation on the chart. So click on that, and say, and if we want to see the goodness of fit, we can also display the R-squared value, and there it is. So what we have here are the R-squared value. This is a statistical measure of how good your data are, how close your data are to a true linear fit. The closer to 1 that is, the better your data are, or the more appropriate the fit is. And you can see this is a very nice fit to linear. Here is the linear equation. So this is the y equals mx plus b. So y is absorbance, x is milligram percent cholesterol concentration. This 0.0169, this is m, so this is the slope. So this is your y, how much does y rise as x increases. And the 0.059 is simply the intercept on the y-axis. Now once we have this equation, this then relates, as I say, how much absorbance you get to how much cholesterol you add to the assay. For our unknown, we know its absorbance. So we can then use this equation, the absorbance is y, we can plug this value of 0.311 into the equation, solve for x, and that will give us our milligram percent. Now we can actually do this in Excel. Excel allows you to do some kind of simple calculations. So to do that, what we would do, we take another cell, and in that cell we type equals. And this then allows us to enter a formula. So this cell here equals this cell, so this is x, and what we're going to need to, this is y rather, and in order to get x, what we're going to need to do is rearrange this equation, so it'll be y minus 0.059 divided by 0.0169. So we can enter that equation in here. So it's going to be this cell, 0.311, which is our y value, minus 0.059 Then we put that whole thing in parentheses. And then we're going to divide it by 0.0169. When we hit enter, it then gives us the value for our unknown. So as I say, all I've done here is I've taken the absorbance of the unknown, I've plugged it into this equation here as the y value, solve for x, and it gives me 14.9 milligram percent. That's pretty good because the actual value of our unknown was 15 milligram percent, so I got very close to the true value. Of course, you can do this in a calculator as well. And in fact, I think I'd probably rather you did this on a calculator so that you can then write out the equation in your notebook. So, get your data, put it into the Excel spreadsheet, plot a graph for the standard of, so this is going to be absorbance, oops, let's let that go away. This is going to be absorbance versus milligram percent cholesterol, and you can type in those values or those titles there. Do the linear fit to the data, get the y equals mx plus b equation, take the absorbance of the unknown, plug it into that equation, and solve for x, which will give you the milligram percent value of your unknown. Now this is kind of nice. Once you've actually made a standard curve like this, so long as you always do the assay the same way, you don't necessarily need to remake the standard curve every time. You've now determined what that relationship is between absorbance and milligram percent cholesterol. So you can then, in future occasions, you can simply measure the absorbance of the unknown, take out the graph that you've already made, plug its absorbance value in, and then solve for the milligram percent cholesterol.